This video is a quick overview of how to make a Wi-Fi plan for an indoor generic office building such as this one. So this plan includes the outer walls, which are concrete, a couple of inner concrete walls as well, some internal brick walls and internal partitions all in glass. And inside this building there's 3 places where Wi-Fi access points are providing signal, and the heat map that we can see is the signal strength that we can expect to receive from the installed network in this building. This model also has measured survey data as well as predicted data that we can see at the moment. And so now I'm going to show you how this indoor plan is built from scratch. So if we remove that and we start from scratch, and then we add the floor plan of the building we're interested in, and we say set as floor plan in new building. The building we're looking at is 52 meters by 15 meters in size. All other new system parameters we can leave as default, and then we end up with an empty model of just the area with the floor plan added to provide layout for the building we're working with. Next thing to do is add the inner and outer walls of this building. So for example, the outer walls are 1 foot thick concrete, so we'll just add them to the outline. There are a few internal really thick 1 foot concrete walls as well, which I'm going to add. And the other walls I'm going to add now are glass. So for example, there's a big glass window on the end of the building, and the internal partitions are also glass. So I'll add them. I'm not adding them in full detail at the moment, just as an overview to demonstrate how this works. And we can also add a couple of double brick walls just for demonstration purposes as well. And now we see just a few of the walls that are present within this building. Now this isn't all of the walls that are present in this building. There are other partitions, there's other brick walls, etc. that I haven't added, but I have previously traced out all the walls on this building, so I'm going to load that one instead. So remove this current simulation and open this one, the other one that I've just dropped onto the window, and then we see the front wall, which is basically a window to the outside world on the end of the building. Internal partitions are glass, outer walls are concrete, and a little bit of brick as well. And so we end up with a model of the structure of the building that we're interested in. From here, if I wanted to, I can just start a plan by adding Wi-Fi access points. So for example, I might add one on the end and one in the middle. And then if I wanted to see what the signal strength or the coverage would be as a result of that network, just from those 2 access points, I can edit the building. I can change the show results to heat map predicted, and then that gives me a heat map which gives me a prediction of the signal strength or coverage that we can expect just by adding, say, a 2.4 gigahertz Wi-Fi access point here and another one here. So we see the signal strength is pretty good around here, and it's around here, but it falls a little bit low in this area, and it falls a little bit low on the end, so we can add another one if we wanted to. At this point, the floor plan is kind of not needed, so we can, if we want to, hide the floor plan, and then we will just see the heat map, which is I guess a visual map of what the expected Wi-Fi signal strength will be throughout this building based on the modelled walls that we've added, as well as the 2 access points. Now, in this scenario, I have been on site into this building and I've done a full survey of the signal strength of the Wi-Fi networks that are available, and so I'm going to remove these I'm going to remove these 2 access points that I've added because we don't need them, and instead I'm actually going to put the floor plan back as well, and I'm going to show you how the survey is done. So now I'm going to show you on the right hand side of this window, this is all the survey related information. So if I click start scanning, it's going to start looking for available Wi-Fi networks, and it's doing this by searching through the Wi-Fi interface built into the laptop that I'm using, as well as there's a USB interface connected as well. And so we see that the Wi-Fi network that I'm connected to, so the network has a name and a MAC address, what interface it's on, signal strength, frequency, channel age, beacon age, etc., etc. We see that there are 2 interfaces available, so if I select filter, I can say I only want to use one or the other interface to survey from, or I can just survey from both. I also see a list of all the networks that are available, and I can select which of these networks I want to scan from if I want to, or I can just turn this filter off to survey all networks that are available, and I see the list of all the networks that are available. So for example, now I've got 91 networks that are being shown. However, if I was to select one interface and to select one filter by one network, okay, I've selected other networks before, didn't I, while I was demonstrating. So at the moment I've only got one network selected, I've only got one interface selected, and I see that that network is providing 3 signals at, so there's 2 in the 5 gigahertz and one 2.4 gigahertz. So I've got 3 signals that I'm capturing at the moment. But for this purpose I can just turn the filters off and capture all available networks. And so now that I'm searching for Wi-Fi networks that are available, or rather capturing Wi-Fi beacons as they arrive, if I click start survey and then I move to a location within this building and then I click on that location after I stay there for a bit, say 5 to 7 seconds, then the captured information about the available networks will get bundled and added to this location. So then I can move to a different location in this building, stay there for a little bit of time so that the survey gets updated, and then I click again and then add another survey point, and at this point I add the updated network survey information, and I can continue on this path as I can walk around this building capturing the Wi-Fi network that's available, and so performing a site survey of this environment. Now I'm not actually on site at the moment, I'm not actually in this building, so I can't perform this survey at the moment, but I have previously been to this site and done the survey, so I'm going to stop the survey, remove this building or remove this network model, and add another one that contains all the walls that I had shown you, as well as this contains all the survey information as well. So we don't need the survey widgets anymore. So in this instance we can see it's the same building with the walls and windows and the internal partitions, etc. But we can see a heat map of the signal strength of the Wi-Fi networks that were measured during the survey. And for this survey, I didn't go everywhere. For example, there's private offices and things that we weren't able to disturb for this measurement. But we can see all the locations that the Wi-Fi survey captured information and what the resulting Wi-Fi signal strength was from the survey that was done. We can also have a closer look at the survey information. So for example, we can list the networks and the signals that were captured as a result. So for example, these are all the networks that were captured throughout this survey, and you can also see that there's 1, 2, 3 interfaces that information was captured on. So on this interface, which is the USB dongle, I'm going to select this network and list the available signals, and then we see a list of all the signals that were captured which formed part of this network. So on this interface, that was the network name, all the different MAC addresses, the frequency band of each signal, the channel of each signal, the frequency, and we can say show me the heat map of this signal which was captured during survey. Then we see this signal was pretty weak and only available in a couple of locations, and we can then look at different signals. So there's quite a few that are weak signals. Most likely that's due to this signal coming from an access point that's not on the level of the building that I was on, but perhaps on the level below or the level above, because it's a 3-story building, and significant amount of signal loss will happen as the signal goes from one level to another through the floor, etc. However, some of these signals will be quite strong. For example, this one's reasonable, and so we're starting to get to see a few stronger signals. So this will be due to an access point that was on the level that I was surveying. So we can now see the coverage or the signal strength that was measured due to some of the Wi-Fi networks that were available in this building. So as we go through, we can then say for this signal, for example, we suspect that it was due to an access point that was located here, and so we can add a source based on this network and this location, and then we can continue through to say this network we suspect was based on this locally, so we can add a source to supply this network in simulation, and we can continue through adding access points for the signals that we see that we suspect are based on a rather served by an access point on this building. And then if I edit the building again as a whole, so at the moment we're looking at the surveyed heat map. If instead we looked at the predicted heat map and just looking at the maximum signal strength, we're going to end up with the heat map, or rather the Wi-Fi signal that's expected based on the access points that I just added. So I added 3 access points, 1 here and 2 here. 2 here because in commercial scenarios multiple Wi-Fi signals can be served from the same device, so we end up with network sources co-located. Now if I look at all the access points that I've added, I can see that, so for each one I've got a name, the network name, the MAC address, band, channel, frequency. All this information gets added directly from the survey information, but there's more information that needs to be added. So for example, the access point transmit power and the gain, and I can get that information from the data sheet of the access point hardware provider. So I've gone to the data sheet that relates to these access points, and I've gotten the transmit power and gain from that data sheet, and I know that at 5 GHz it transmits at 24 dBm, and at 2.4, whoops, my bad, at 5 it transmits at 26, not 24, and at 2.4 it transmits at 24, and the gain on this access point is 4 at 2.4 gigahertz and 6 at 5 gigahertz. So I can update the gain and the power and then apply, and then you'll see the coverage is increased as a result. And so if we look at, so this only has provided the information on 3 access points that are here. However, I have gone through all access points or all signals that are present on this level of this building in a different model. So I'm going to remove that and open the other one. So this model is the one that I had open at the beginning of this video. So it's the same building containing the same survey information, but I have gone through and added all the relevant information for the access points that we're interested in. And so we can see there's 8 access points present. All the information is loaded in here. So for now was I was interested in further analysis on the information here. So for example, I wanted to look at the difference between what was calculated and what was surveyed, etc. I can go export, make a directory, export into it, and then I get all the information that I've captured and calculated relating to this model into a set of CSV files. So I can then open one. So this file gives me every transmitter that's here, every receive point or sample point or survey point that's here, and it tells me the transmitter information, so MAC address, etc., frequency, So what I can do is filter on the top row, and for the measured column I'm going to filter out -1000, which is invalid data. So in this survey there's a sample point at each location throughout this whole heat map. However, not every location has a measurement value, whereas the sample points that I added through the survey each has a measurement value and a simulated value. So if I filter out the measured value of -1000, then I end up with just the sample points that have a simulated value and a measured value. And then I can graph this data. So calculated and measured value versus distance. Insert that as a chart. And then I see a graph of the power measured in red versus calculated in blue, and see the calculated power is lower than the measured power. There's a couple of reasons for that, one being that the path loss function here is line of sight. No, sorry. Path loss function here is non-line of sight, whereas a lot of this is open space, so a line of sight path loss function might give a better result. Another is that the detail level is medium, setting a higher detail level can improve results as well. If, for example, we filter this data by just the 5 gigahertz, we see that we can look at what error levels we have there. We can, sorry, that's 2.4. So there's a lot of room for further analysis here, but this gives us, and we can also close the exported data and look visually at a comparison between calculated and simulated heat maps. So for example, if we were again to look at all the networks and signals that were available and just filter out the networks we were interested in, which is the ones that we have surveyed and predicted heat maps for, so we can list those signals. And then for each of these we can say, for this one, what does the surveyed heat map look like? And we can do this for all of the available signals that we have. And then if we were to pick one and compare, say, the heat map that was calculated versus the heat map, or the heat map that was surveyed for the signal, and compare that to the heat map that was calculated, we'll see the coverage is comparable. And we can do the same thing for other signals as well. So for example, here here's the measured heat map for the signal, and then we can compare that to the calculated heat map for this signal. And if we weren't happy with that result, we can then, for example, change the path loss function. So because this building is there's a lot of open space, if we were to open the propagation tab under the building edit and change it from non-line of sight to line of sight. Then we recalculate and we'll see a further range achieved, which is more consistent with the results because the measurement was taken in the building with more line of sight than non-line of sight type of environment with less obstructions such as glass, etc. So that gives you a quick overview of how to generate a heat map or an indoor Wi-Fi plan using EMSlice software product. Everything I've done here, or most of what I've done here, can be done with the free trial version, which is available from the website. Happy to take thoughts, comments, questions, feedback. We have our email address is in the video description as well. So thanks for watching.